Today we're going to go over the big ideas for section 1.3. First thing, measures of center. We have the mean and the median. So to find the mean, you take the sum of all the data values. And you divide it by the number of data values. For example, if I had the list 1, 3, 4, 5, 7, I would take 1 plus 3 plus 4 plus 5 plus 7 divided by the number of terms, which is 5, to get out a mean or an average of 4. Now the median is the middle point of a data set. So with that same set of data, you just cross off from left and right until you get to the middle. So 4 would be your median in that set. If I added one number to that, so let's say I added an 8. Then if I cross off from end to end, I'm left with 2 numbers in the middle. So your median is right in between those. What you do is take the average of those two. So 4 plus 5 divided by 2. 9 divided by 2, 4.5. So if it lands in between, take the average of the two. Then we want to talk about measures of spread. The range is the maximum minus the minimum value in your data set. So with that same 1, 3, 4, 5, 7, the range is 7 minus 1. 7 is your max, 1 is your min. You get out 6. Now, standard deviation is a whole big fun formula. The square root of the sum of the individual values minus the mean. So x bar is the mean, x subscript I is the individual values. You square those, and you divide by the number of values n minus 1. So doing that, in this problem, we take each individual value, so the first one was 1, minus the mean of 4, square it, add them all up. So then 3 was the next value, minus 4, squared, plus 4 minus 4, squared, plus 5 minus 4 squared, plus 7 minus 4 squared, all over the total number of terms from our list, which was 5 minus 1. If you do all that, you get 2.24. Eventually, I will show you how to do this on a calculator in another video. How is data affected by outliers? So if I have that same list, the mean is 4 and the median is 4. An outlier is something that doesn't fit the normal pattern. So let's say we put a 20 on the end. That's way higher than the other things. What that's going to do to the mean's going to go up by a lot. So this 20 is going to greatly affect the mean. But the median, if we simply cross off, is only going to change to 4.5. So outliers affect the mean more than they do the median. And if you have skewed data, you should use the median. For symmetric data, use the mean as your measure of center. Next, we're going to talk about the 5-number summary. So that is Q1 the minimum, Q1, the median, Q3, and the max. All right. So, as an example, we have the list 3, 4, 9, 11, 14, 18. The minimum is the 3, max is the 18. The median is directly in between 9 and 11, so the average of 9 and 11 is 10. To find Q1, Q1 is the median of the first half of the data. So if I cross out, Q1 is 4. And the second half of the data, that's Q3. So the quartiles are the medians of first half and second half of the data. So Q4 is 14. So that is the 5-number summary. So median Q1, minimum Q3, and maximum. That 5-number summary displayed in a graph is called a box plot. So a box plot looks something like this. You take your Q1, you go to, this is your minimum. This is Q1. Your median is inside the box. Q3 is out there. And your max is here. Now this doesn't always look symmetric. It can look like this. It can be spread out in different ways. The important part is your box contains 50% of the data. Outside is 25% on each side. And from the median to either quartile is 25% as well. So the box contains the middle 50%. If we want to calculate outliers, we need to find a lower fence and an upper fence. To find the lower fence, we take Q1 minus 1.5 times the IQR, which stands for interquartile range. We'll talk about that in a second. To find the upper fence, you take Q3 now plus 1.5 times IQR. So I'm just going to write that same data set we had last time. Q1 was the 4, Q3 was the 14. So now to find IQR, you just take Q3 minus Q1. So 14 minus 4, which is 10. We know the IQR is 10. So 4 minus 15 is negative 11. Now Q3 plus 1.5 times 10 is 15. We get 29. So those are our upper and lower fences. So if you notice, there's no numbers below -11, and there's no numbers above 29, so there are no outliers.